Hallo und herzlich willkommen zu einer neuen Folge vom Podcast Software Testing. Heute wieder mit einer Folge von der OOP 2024 in München. Zu Gast bei mir gerade war Eoin Woods. Mit ihm habe ich darüber gesprochen, wie man Security by Design umsetzen kann, welche Prinzipien man verfolgen kann und wie wir das in einen Entwicklungsprozess umsetzen können. Weil wir kennen das doch alle, wenn Security getestet wird, ist das Kind oft schon in den Brunnen gefallen. Die Folge ist auf Englisch, aber ihr werdet trotzdem viel Spaß damit haben. Hello, Eoin. Fine to have you here on the podcast show.
Well, thank you. Thank you for the invitation. It's very nice to be here.
Yeah, it's great. We had I think it was the last preparation call I had for the OOP conference, and so we get this slot now, and I'm very happy to have you here because you have a very interesting topic in my opinion. Because in testing we have often the part to test security things, and that's always a thing which happens too late. And you have the speech here. Your talk is about security by design. So make security
a first-class citizen.
Yeah,
yes.
Yeah,
as opposed to the thing that's always shoved in at the end.
And
nobody wants to touch. Exactly.
Yeah,
that's
great.
the whole idea.
Yeah, great. Yeah, so let's start into this topic. What are your ideas to that? What are your expectations to make security by design?
Mm-hmm. Well, the really interesting thing about security is that I worked in security engineering briefly, and I worked in a number of places where security is very important. This was back many years ago. And then when I started working even in large financial organizations, it was quite hard to get people interested in security. So about 10 years ago, I started giving talks on it, and I used to get 5 people in the audience, and they were all security people, and I was just talking to people who knew about security. And then the amazing thing that's happened is that now you get a room full of people who actually want to know about security. So that's just fantastic. Something's changed, and it's a really, really great trend. But the thing that I think that still persists is exactly what you talked about a moment ago. It's not just security, is it? Security, performance, resilience, availability. They're all things that, of course, we know they're so important, and we will get round to them eventually. And that's what just never works. As any tester will tell you, if you start thinking about security in the last 10% of your project, you're going to get 10% security. So you really need to start early. The difficulty with that practically is that most software engineers don't have lots of background in security. It's changing a little bit. Some university courses today, and I observe, at least in the UK, are starting to have a lot more security right from the first year, and that's terrific. But a lot of people in the industry, they know about security in abstract terms. They know that they've got authentication and authorization and auditing and so on. But actually, what do you do? And then when they try and engage with the security community, they meet security engineers. They're very clever people, and that's all they do. And the problem is, that's all they do. And they don't know much about software delivery. They've typically come from an infrastructure background, or if not, they did a bit of development years ago, and now they do security, and they just speak a different language. And they will very quickly overwhelm a software team with all of this complicated stuff the team absolutely has to do now, otherwise there will be a disaster. Whereas, of course, we know that nothing's absolute. Everything's got to be a balance. So one of the things I noticed was that principles really help people. I'm a big believer in design principles to help guide design decisions. And quite a long time ago now, I realized if we could identify some principles that were easy to understand and remember, that might just get people thinking about security much earlier. And that's when I came up with this set. The reason being, I didn't really want to invent a set, but I went out to look for them, and there were sets everywhere, from like minimal sets with 8 or 9 up to, I found one that's got hundreds of principles in it. And they're all valid, but how would you possibly use it? So I tried to find a middle ground. It distills them down to a set that's pretty accessible, but I think covers a lot of what software teams need to understand about security.
Oh, very good. So let's look deeper into these 10 principles. So maybe we look at how much time we have. So maybe we start with your top 5.
Sure. Some of the important ones are things like defense in depth. It's very common today that we have very sophisticated attackers. You can't assume that one security mechanism, say a piece of encryption or an authentication system is going to protect you. They may well defeat one of your mechanisms. It's really great to have more than one mechanism so that once they're in, they haven't got everything. So defense in depth is quite important. The other thing is that nearly every security mechanism has flaws, or we make mistakes in how we apply them. So it's important not to be totally reliant on one kind of security mechanism throughout your system. So in really secure systems, those that, for example, governments defend, you'll find every single layer has its own security mechanisms. They're all independent. They all interlock. You can break in to one level, you've just got the same problem again and again and again. And what they're trying to do is make it very expensive to break in. So that's one thing I always remind people, don't depend on one thing. The other thing, which is unfortunately still quite common, is don't invent your own security technology. It's a lot harder than it looks. Nearly every relatively inexperienced software engineer I've met thinks that how hard can encryption be? I read a book on it recently. I'm going to create my own password vault. I just go, don't. It sounds fun. It's a lot harder than it looks. And that goes for all kinds of mechanisms, even things that look quite straightforward, like integration into maybe OAuth, into authentication and authorization systems. If you can possibly do it, find a library that does it for you already. And the reason is because even security technology produced by the experts, by the professionals, it's got flaws in it. The first thing they do when they produce it, they start beating it with all those expert security testers start testing it immediately, and they always find problems with it. What are the chances that you're going to have no problems with yours? It's pretty slight. The other thing is just that honestly, it's an overhead you don't need on your project. I know it looks fun, but honestly, perhaps there are better things you could be spending your time on.
Do you recommend to if you think about libraries doing the encryption stuff, to go to open source because it's more transparent what happens there, or closed source from companies? Do you have any?
I think it's quite context dependent, actually. I don't think either has a monopoly on good security. You're absolutely right. The transparency around open source is quite reassuring. There's a lot of independent security researchers looking at that stuff all the time. But in certain markets, for certain applications, actually there are closed source solutions which they're really the superior offering. You have to ask the right questions of the vendors, but they may be the right choice in your case. I mean, I personally tend to veer towards the open source ones, but it really does depend what you're building.
And are there any principles to fit on the process of how I develop software? So I can say that don't build your own, use it, but that's one point on the whiteboard at the top, and nobody sees it because they are doing their daily business. And how can we deal with that?
Well, really, the design principles are, I'm aiming at designers. It's the things they should be thinking about when they're doing their design. You're raising a much bigger and very important point, is how does the whole team go about doing secure software delivery together? And really, they need a secure software delivery lifecycle, which is just a sort of posh name for saying make sure you do the security work all the way through the lifecycle. There are a number of industry standard models. OWASP are a great organization, full of resources, and they have a secure software development lifecycle that you can use. It's very well developed. It's been used by lots of people. But there are a number of models for secure software delivery out there. A number of government bodies have them as well, for example. So that I always recommend start from a secure software development lifecycle from experts. Of course you'll tailor it. Everyone tailors software development life cycles, but start from one that's been used already.
I think we have to implement into the process that it is more of a lot of clients. For me, there is security one part of the non-functional requirements, and if they are written in any user stories, it's often too late to think about it. What does it mean to make this or that? So
one of the things we always recommend is to bring security user stories into the process, so-called abuser stories. How is someone going to attack this system? That's a sort of simplified version of a technique which is in all this secure development life cycles called threat modeling. And that's where it sounds complicated. It's really not. It's about sitting the team down and saying, okay, what have we got that's valuable? Who would think it was valuable, and how would they attack us in order to get that valuable thing? Could be a piece of data, could be a financial transaction, could be an operation that they want to either enable or disable. But it's a question of going through that process in a structured way. And there's a number of very good books out there. Adam Shostak's is the classic one on threat modeling, but there are actually quite a number, which are all very good. It's as the real experts in threat modeling like to point out, it's a really simple process. Don't overcomplicate it. But just go through the process of thinking out what could go wrong.
Yeah.
It's a little bit like with high availability. Yeah. You need to sit down and work out everything could go wrong. What will happen when each piece of this goes wrong?
Yeah.
And once you've been through that process, you're in a much better place to know how robust your system is.
I understand. Often, security is the hackers and all the cyber stuff. They use a lot of day zero ports to vulnerabilities to get into a system. Is there any part we can address this new up-to-date mechanisms to solve in our design?
I think it's really tough, actually. One thing is defense in depth, we just talked about, is that if you're relying very much on one component to keep you safe, if it's got a 0 day, then someone's going to exploit that. The other thing I think is around processes, you were saying. Do you have a strategy for keeping your components up to date? But in the days of open source, that is really difficult. Some ecosystems, the Node.js ecosystem would be a great one to use as an example. They have such fine-grained components. You've really got to have automated help to stay on top of that. One of the other principles in my set is trust cautiously. And there's a number of things that implies. One of them is, for example, network connections don't either make or accept authorized and authenticated network connections. But another one is be careful what you insert into your system, what you bring in. Could be data. Be cautious about what data you accept, because there are lots of exploits that involve putting malicious data into a system. But also think about what you're building it from, and not just open source. Commercial stuff, commercial libraries, for example, you're using as well, or commercial platforms. How secure are they? And as you very rightly point out, if they had a 0 day, how would you know, and what would you do? And unfortunately, 0 days are a really intractable problem, if nothing else, because there is a black market in 0 days. So actually, even knowing they're there can be difficult. There's only so much we can do, but definitely knowing what's in our system, and probably having automated support, particularly for the open source, for keeping on top of if there are vulnerabilities in our components or not, is really important.
I think there is a big, huge problem. What you mentioned is which data is can I put into my system, or will I allow to put in my system? I know a lot of clients, they have a landscape of applications and driving through their data, and all the APIs are very lazy stuff, so they are letting all through, and I think there is a big security issue there, because some of these infections can go through all the systems and then making Big Bang here on every edge. So I think that's a big point to look how secure are my contracts or my APIs, and to make a good interface.
I think you're absolutely right. It's a bit of a trade-off, isn't it? Because the simple thing to do is always lowest common denominator, make everything a string, because that's going to be really straightforward, and you're not going to reject anything. Everything will get translated to a string somehow. But you're right. You can then people can craft very clever malicious attacks that send you malformed strings that your string processor thinks are fine, but then when they're translated to something else, actually perhaps just cause a failure, and so it's actually denial of service attack, or perhaps do something actually much more subtle and malicious, which ends up in, for example, remote command exploits. It's something you've got to be really careful about. The trade-off is really strongly typed interfaces take longer to develop, they're less flexible, they're more difficult to evolve. So I understand why people want to make them very flexible, but always bear in mind, if you're not validating things really, really carefully, as you say, as soon as you've got the ability to take large amounts of unformatted data in, you've got potentially a huge security problem.
That's true. What other principles are in your set, so we can go a little bit deeper there?
Sure. So other ones would be making sure that you use secure defaults and that you fail securely. My classic example of this goes back many, many years. When you used to install relational databases, Oracle was a classic example, they always enabled 3 or 4 very powerful accounts with standard passwords.
Yeah.
And in most enterprises, if you knew about this, you could go up to an production Oracle system and find at least one of them still had the default password. It was a security cliche for many years. Have you got Oracle? In that case, you'll have a Scott Tiger account, meaning there was a user called Scott with a password Tiger. It was a demo user. You could get into almost all the Oracle systems. Now, Oracle did, to be fair, fix that many years ago. But an awful lot of open source stuff or cloud demonstration software does come with standard logins. They're unlocked and they've got standard passwords. Similarly, network hardware. I'm still amazed how much enterprise-grade network hardware comes out with default users and passwords installed, because of course it's convenient. Well, we know it's convenient. It's completely insecure, really quite dangerous. And the related thing is, it's a bit like that. Don't fail to an insecure position. So a classic example is years ago. I know of a database vendor who was very, they were very concerned about their performance and their availability, and they were well known for it. Rock solid database used by big banks for transaction processing, that kind of thing. And they had this problem that it luckily didn't get beyond the beta stage, but they built an audit into their database. The customers had asked for it, and this seemed very sensible. It got this rigorous audit trail that was tamper resistant and banking grade, as people like to say. And then what did the engineers do? Well, of course, the engineers were very concerned about performance and availability. So if the audit started malfunctioning or filled up, they disabled auditing and continued processing, because of course they were completely focused on performance and availability. Luckily, it got to beta, and some customer went, "No, hang on a minute. Our audit trail filled up, and then you just continued processing without the audit trail." But you can see how the trade-off happened in someone's mind. We are the performance and scalability database. Therefore, auditing's optional. Oh, no, just a minute. No, it's not. Similar thing if you, years ago when Unix systems used to panic, they used to come up with a prompt you could get into root without a password. Subtler things today are things like when you've got message-driven systems, what happens when you get a complicated multi-component failure and you bring it all back up again? Does everything authenticate correctly and refuse to process until you've got end-to-end security in the system, or does it just start processing opportunistically? Will something always wait for all the security services to be available? Those kind of questions.
Very, very interesting parts. I wonder, how can we put more awareness in the design phase to mention all these points, these principles, because a lot of clients are very feature driven, where we have to go
very much so.
So how can we argument that we have to do this work?
I'm amazed the testers asking me that question. The answer is testers, because testers always think about what can go wrong, and that's such a valuable service, because most people aren't. I like to think software architects are always thinking about what could go wrong too. But they're only human. They're often under lots and lots of feature pressure. Or they may have very specific quality attributes that have been a problem up till now. Say it's throughput, and they're very focused on throughput. They know security is important, but they're very focused on throughput for the 2 or 3 sprints. That's a great job for the tester to go about this security stuff. We appear to have just ignored it for a while, and I'm quite concerned about this new feature. It appears to bypass the security control. That's just exactly what we should be paying testers to do. But also, of course, supporting testers so that testers feel they're being encouraged to ask those questions. There's always a danger the tester feels that actually they're quite unpopular for asking the difficult question. We should be embracing and thank you so much for asking that question. Otherwise, we'd have made a mistake.
I think it's good for all in all this agile and DevOps stuff, so that the testers can got into the team earlier in the process. In the past, where the tester was the last one who sees the software, said, "Oh my God,
yes, what have you done?" Yes. The other person, of course, to get involved is your friendly security engineer. Ideally, one who's got an application security background as well as infrastructure. And make sure that you're asking them all the right questions, and you're inviting them in to do some threat modeling with you, be asking you all the questions that you might not have thought of. If you've got a pen test team in-house, you might not want to use them for the final tests, but they're very, very valuable earlier on. Get them pen testing things early. Maybe everything will fail.
Yeah.
And probably that's okay right now, but you're suddenly getting everyone thinking about this needs to be secure, and currently we're not.
Yeah.
So we need to put the effort in.
Yeah.
And maybe even the product owner, who knows,
Yeah.
might finally go, oh yeah, actually that's a big problem.
Yeah.
I need to spend some more time on security.
Yeah, great. Eoin, thank you very much for this inspiration, for these tips for us. I think we can use it in our projects and in our teams to think again how to make our systems more secure and to think security upfront and not in the testing phase at the last one. So thank you very much for these insights here.
Thank you very much. It's been a pleasure. I always love to talk security.
Yeah, thank you. Have a nice conference here.
Thank you very much.